formulas that we have. We've got the volume. Basically, if we're going about the x-axis, we're going to use this. We need to come up with the area formula, and I'll show you how that works. We are combining kind of our top minus bottom function thing from finding volumes with an area formula. A known cross-sectional area. Do you know the area of a square?
Yes.
Do you know the area of a circle?
Yes.
Area of a triangle?
Yes.
Okay. We're going to use, those are what we call known cross-sections. Known cross-sections. Okay, and they're very specific, so here's an example of a problem. We want to find the cross-sectional area. Don't want to do that one. Okay, so find cross-sectional, find volume using cross-sectional area. Okay, so we've got our function here. Our base is bounded by x squared plus y squared equals 4. We're going about the x-axis. And for part A, our cross-section is a square. Okay, so I'm going to draw a little picture for you. The first thing we need to do is draw our base, and my base, in this case, it looks like it's one function. This is actually two functions. Okay. They might give you two functions. Your base is like an area between two curves is what it is. So I'm just going to sketch this. This is actually, if you think about it, since we're revolving about the x-axis, we need a function, we need y by itself, don't we?
Yes.
So if I get y by itself, I subtract x squared and take the square root. And so y is equal to the positive and negative square root of 4 minus x squared. That's how you get the two functions. The positive and the negative. Now, if you look at that function, what's that function just by itself? If you graph it. No. X squared plus y squared equals 4. That's a circle with a radius of what? 2. Circle with a radius of 2. Circle with a radius of 2. Okay, so the positive part is up here. That's y equals the positive square root of 4 minus x squared. Down here, this is the y equals the negative square root of 4 minus x squared. So that's how you get your two functions. So in relation to the x-axis, basically two functions. We're revolving this. Do you really need to revolve both functions to get a solid? No, you don't, okay? I'm just trying to get you to visualize a little bit of what this shape is. So if I revolve this around the x-axis, what shape, who knows what shape I'm going to get? I'm going to get a sphere. So basically I've got a sphere. If I'm revolving this around the x-axis, I end up with a sphere, okay? And, but the way I'm going to find the area of it is I'm going to use cross-sections that are what shape? A square. A cross-section means if I slice this thing, I'm basically slicing it. And so I'm going to create in here, first I'm going to draw, basically if you're looking at it straight from the side, the square just looks like this line, right? This, doesn't it? Perpendicular to our axis of rotation. But on the side, it'll look more like a square sitting in here. Okay, and that's going to rotate around. How do you get a
Explain that one more time, just exactly.
Well, if you think about, I mean, this is just looking at it straight on, top to bottom, right? If you look at it three-dimensionally, I can make it into a square. You create a square in there.
You have to think about the sphere.
You're inscribing a square in the sphere. You're inscribing a square inside the sphere. Okay? So, we're going to find the volume of this using this cross-sectional area. So what is the general area of a square? Area of a square. Side squared. Okay? Area of a square is side squared. Period. End of discussion. No other formulas. So the area, A of x, and I'm going to call it, instead of calling it the side squared, I'm going to call it the base, b squared. Because the base, we talk about, this is the base here. The base is bounded by the circle. So it's whatever the base squared. So now we need to find, basically the base is this distance from here to here. Now we need to figure out what's b. What's the base? How far is it from here to here? What is that distance? And that distance, I mean, that base can change depending on where you draw your cross section at. So what's the top of this? What function? Square root of 4 minus x squared. What's the bottom of this? Negative. So how do you find the distance? Top minus bottom, right? Top minus bottom? Yep. Isn't that how? Okay. Yep. Area between these two is top minus bottom. Would you agree?
Yeah.
Okay. So here's the top minus the bottom is negative square root of 4 minus x squared. So the base ends up being what? 2 square roots of 4 minus x squared. So the first thing you have to do, you have to find what's the area of my cross section that I'm using. I have a square, so the area is base squared. What's my base? My base, my b, is based on my functions, top minus bottom. Okay, so now I found my base. Now I use my formula. The cross-sectional area was the integral from a to b of capital A of x dx. Well, what's my area formula? B squared. But what was my b? 2 square root of 4 minus x squared, and I need to square that. So now I need to figure out where I'm integrating this on. Where does this area start and end on the x-axis? Negative 2 to 2. All right, so let's simplify this. The integral from negative 2 to 2. 2 squared, 4. The square root of 4 minus x squared squared. And now the integral from negative 2 to 2 of 16 minus 4x squared dx. And from here, can we use our calculator? So now our known cross sections are equilateral triangles. So now our known cross sections are going to be equilateral triangles. Okay, so equilateral triangle is like, now I put a triangle, please stop talking. I put a triangle in here. This is a side view. This is if you just turn it at a slight angle. You've got all these little triangles that you're going to use. So I'm going to draw the equilateral triangle out here. What's the area of an equilateral triangle? 1/2 base times height.
It's equilateral, so wouldn't it be base
No,
squared?
because this is the height, and that is not the same as one of the sides. The height is always the distance from the top. Okay. So what was the length of the base that we already figured from the square?
2
2 square root of 4 minus x squared. So all of these are 2 square root of 4 minus x squared. All of them are the same as they were, as what it was when we had a square. Okay, but what's the height? Okay, this is where what kind of triangle is this going to be?
All right.
30, 60, 90 right triangle, right? Because isn't that 60? Equilateral, 60, 60, 60. So this is a 30, 60, 90. Okay, how long is that right there?
Square root of 4 minus.
That part's just the square root of 4 minus x squared. In a 30, 60, 90 triangle, isn't this like the small side and then this is twice the small side? What do you multiply the small side times to get that side? Square root of 3. So the height is the square root of 3 times 4 minus x squared. The base is twice the square root of 4 minus x squared. Can we find our area now?
Is it always going to be square root of 3 times?
If it's a 30, 60, 90. If it's a 30, 60, 90. All right, so now we can write our volume formula for area. Volume is equal to the integral from where to where? Where are we integrating on the x-axis again?
Negative.
-2 to 2 of my area function. So my area function was 1/2 base times height, wasn't it? So what's my base? 2 square root of 4 minus x squared times what was my height? Square root of 3 times the square root of 4 minus x squared. Now can we simplify that a bit? Half of 2, 1. That square root of 3 is just going to sit there, times, what do you get when you multiply those two? 4 minus x squared. Can I just pull that radical 3 out in front and like not mess with it until the very end? So my antiderivative will be radical 3 times antiderivative of 4 minus antiderivative of x squared, x cubed over 3. Now we need to plug in 2 and -2. So when I plug 2 in, I get 8 minus 8/3. When I plug in -2, I get -8 plus 8/3. Distribute that negative. So I'm going to get radical 3 times 8 minus 16/3. 8 is 24/3, right? 24/3 minus 16/3.
Well, it'd be 16.
16 minus 16/3.
So it's 40 minus
16 minus 16/3.
plus 8 plus 8.
Oh, yes, thank you. 16 minus 16/3, so 48/3 minus 16/3 is 32.
Yep.
So 32 radical 3 over 3.
Don't forget that radical.
So what if you were asked, and your cross sections were semicircles? What's the area of a semicircle?
2 pi, or 1/2.
1/2 pi r squared.
Oh, no.
That's the area of a semicircle. I think that's the only other one that you need.
And then the radius would just.
The radius would be, like if you did a semicircle, the radius would be half of a base. So radical 4 minus,
So it's like you're doing the same thing except rotating half a circle.
yes. It's kind of crazy to think about, I know.
They just rotate it.
That's part of the reason why I haven't taught especially this before, because it's so hard to visualize what's going on. And I know this level of student, you typically want to like be able to put it in your hands and hold on to it, you know what I'm saying? Like I want to understand what it means, so, but